I am from Anderson Junior College, and together with my teammates Benjamin and Megan, we are delighted to be able to share with you on our research project on copper oxide nanowires. Basically, we believe that through laser irradiation, we are able to improve the conductivity of nanowires. This is because the laser irradiation is able to weld the nanowires together, thereby reducing the contact resistance between the individual nanowires. Our objective is to find out the feasibility of copper oxide nanowires in the electronics industry. Why copper oxide? Well, copper oxide really gives bang for the buck. For a relatively lower price compared to silicon, it actually displays quite similar characteristics in terms of its conductive properties. We choose to do our experimentation with a nanowire array instead of a single nanowire, as there is limited experimentation done on this nanowire array system. Also, the other consideration is cost. For the time at least, it is not economically viable to extract single nanowires at an industrial scale. By contrast, the preparation of a copper oxide nanowire array is a much simpler process. Simply heat up the copper foil on a heating plate for 8 hours at 500 degrees Celsius. The copper will react with oxygen in the air to form copper oxide, and nanowires will grow perpendicular to the surface of the sample. Then, simply rub the foil onto the silicon dioxide substrate and the sample is ready to go. Now, I'll pass on to Benjamin.
Thank you, Hao Jie. After obtaining our sample, we will then have to characterize it. This will ensure that our samples are indeed copper oxide and not other oxides of copper. Therefore, we will then perform Raman spectroscopy on it. The results we have obtained from our samples actually matches the results that we have searched on from our literature research. This proves that our wires are indeed copper oxide nanowires and not other oxides of copper. So after which, we will then sputter electrodes on our sample. This is because nanowires actually do small for our electrical probe to probe individually. So what happens during the sputtering is that we will place a shadow mask above our sample, after which gold ions will then get beamed down. The gold will then cool and get deposited on our samples, after which we will then remove the shadow mask which would leave behind rows of electrodes perpendicular to our sample. After which, we will then perform electrical property testing on our sample. We will place electrical probe on each electrode and attach these two probes to a source meter. The source meter will then generate a potential difference which will cause the current to flow in our sample. The source meter will then record the electrical readings. After performing our electrical property testing, we will then move on to laser irradiation. What happens during laser irradiation is that copper oxide nanowires melt and fuses with neighboring wires. This actually helps reduce the contact resistance of our nanowires. So this is actually what happens during our laser irradiation. The laser will cut parallel to our samples, preventing our nanowires from being cut, which will increase our contact resistance instead. We chose to work with a power of 10 mW, as power of 10 mW will actually cause the entire nanowire to melt and increase contact resistance instead. After laser irradiation, we will then move on to another round of electrical property testing for comparison. I will now pass it on to Megan to talk more about our results. Thank you.
Thank you, Benjamin. So after everything, we have obtained a graph and a set of table values. Okay, so our graph roughly follows that of the semiconductor, and at several points throughout the graph, you can see that there's actually a decrease in the resistance from 5 to 1 and from 1 to 5. We could attribute the graph to have such a shape because of the Schottky effect, and this is so because the Wolf function value for copper oxide is relatively much lower than tungsten and gold. So after that, we'll move on to further experimentation and applications. So we can apply a 4-point probe test, which is actually a more accurate way of reading off values in the entire circuit, and this would help improve accuracy. And next, we could combine copper oxide with zinc oxide to form a PN junction, and we could see how feasible it is as such a semiconductor. And next, currently we have examined how silicons are produced, and they are quite expensive and relatively larger than our samples. And furthermore, it's much more expensive, as you can see from these figures here. So far, copper oxide seems to be on the right path for being able to overtake silicon. So in conclusion, we can therefore conclude that laser irradiation can cause our copper oxide nanonets to actually improve in conductivity, and this could possibly be used in the nano industries because of the lower cost production and the simplicity of production. Therefore, our this is proven.